There are 8 characteristics of the memory system. That is location, capacity, unit of transfer, access method, performance, physical type, physical characteristics, and organization. The first characteristic of computer memory system is location. Location refers to whether memory is internal or external to the computer. Example of internal memory is processor registers, main memory, and cache. And for the external memory, the examples are optical disk, magnetic disk, and tapes. The second characteristic is capacity. For internal memory, this is expressed in terms of bytes or words, but for external memory, it's only expressed in bytes. The third characteristic is unit of transfer. For internal memory, the unit of transfer may be equal to the word length, but is often larger. And for the external memory, data are often transferred in much larger units than a word and called blocks. The fourth characteristic is access method. There are 4 types of access method, which are sequential access, direct access, random access, and associative. The fifth characteristic is performance. The performance parameters are used is access time, memory cycle time, and transfer rate. The sixth characteristic is the physical types of memory. The most common are semiconductor memory, magnetic surface memory used for disk and tape, and optical, and the last is magneto-optical. The seventh characteristics is the physical characteristics of data storage. In volatile memory, information decays naturally when no power supply, but for non-volatile memory, information remains. The last characteristic is organization. For random access memory, the organization is a key design issue. By organization is meant the physical arrangement of bits to form words. The obvious arrangement is not always used.
3.
Let's start. The design constraints of computer memory can be summed up by 3 questions. That's how much the capacity, and how fast the processing time, and also how expensive the cost is. The memory unit is the essential computer component in any digital computer because it's needed for storing programs and also data. The memory hierarchy system consists of all the storage devices employed in a computer system, from slow to high capacity auxiliary memory to the relatively fast main memory, and to even smaller and faster cache memory. The auxiliary memory refers to the backup device such as hard disk, and the main memory are used to communicate directly with the CPU, while the cache memory enable the processing time to be the faster. And in the memory hierarchy, this is used because the designer need to have the large capacity memory and also the expensive, relatively lower capacity memories with short access time. As we go down the memory hierarchy, we can see that it will have decreasing cost per bit, increasing capacity, and also increasing access time, and also the decreasing frequency of access of the memory by the processor. The main memory occupies a central position by being able to communicate directly with the CPU and also with the auxiliary memory to the input-output processor. And the cache memory is a very special and very high-speed memory, which is used to increase the speed of processing by making the current program faster. And There's the use of two levels of memory to reduce the average access time work in principle, but only with the condition true and applied, which use the basis for validity of condition by a principle known as the locality of reference, which is DENN68. And during the course of execution of the program, the memory reference by the processor for both instruction and also the data tend to cluster over a short tend to cluster together, and for a long term of time it will the cluster will change, but for a short period of time the processor is primarily working with the fixed cluster of the memory reference without any changes. And so by using this processor working with the small cluster of the memory reference is similar to what the memory hierarchy did. Accordingly, the possible to organize data across hierarchy is that the percentage of access to each successive lower level in the substantially lower is substantially lower than the level of the level above. So in the memory hierarchy, the level above will use more access time than the level below it. That's all.